Hello.
Hello, everyone. Can you hear us? Welcome to our 25th edition of the Service Fabric Community Q&A.
All right. So the way that this normally works, in case there are folks here who's it might be their first time, we might update you on some news, some things that are coming, and then we basically always make sure that we leave lots of time to answer your questions. You can talk at us. You can also just dump your questions into the IM window, and we'll answer them as they come in. So, whoa, somebody's ready.
Yep. Yes, they are.
Yikes. Okay, good work.
Oliver. We love it.
Oh, Oliver. Okay, good. I can see you've been waiting. Major updates. I think we're still working on mesh previews. Those continue to come out. Private Preview 3
just came out.
Yeah,
and 4 is on its way.
And 4 is on its way, and then we're looking to hopefully get to public preview soon. We're basically kind of evaluating the feedback that comes in from the previews. So thanks to those of you who are already participating. If you're not already in the mesh preview and you'd like to be, we can send out the sign-up link.
Yep.
Get your information and get you into the queue. Right now, a lot of the whether or not you're in mesh or not is basically on whether or not you've signed up and how much capacity there is.
And demand.
In demand, yeah. We've actually got a lot of people in the queue.
Yes, we do.
So don't get demoralized. The private previews will be ending sooner or later, and everyone in the queue will get the public access when we get there.
Right.
But for those of you that are giving feedback in the meantime, we really do appreciate it. I think unless there's any other major announcements or stuff you want to talk about, guys.
I don't think so.
On the road to mesh.
On the road to
In the
mesh.
meantime, I guess we'll just start.
On the road to a lot of things.
In the meantime, I guess we'll just start answering Oliver's questions.
Okay.
All right.
Well, I guess that leads into his first question.
Yes.
Which is the general buzz, is that mesh is the future of Service Fabric. So the question is, I guess, what's going to happen to existing Service Fabric and the way you write applications today? Well, so none of that's going away because most of the new work that's happening. So let me back up a little bit. So by now you've probably seen a little bit about the resource model that we have in Service Fabric that we're developing, which is kind of a new way to deploy workloads and things, for lack of a better term, to Service Fabric, which is a kind of a YAML JSON document model where everything's represented as a resource and you can deploy things on an individual basis. And so the question is, what happens to the current manifest model where you have application manifest and service manifest? So those aren't going away because all this stuff is kind of layered. So all the resources that we write, they're actually built on top of that manifest model. So you won't see that go away anytime soon and probably ever.
Yeah.
It's true that probably a lot of the investments we make, the new investments we make will be geared a little bit more towards that resource model because it's a little more flexible for us. There's more things we can do with it. But
I also think that it's a better model for people who are getting started.
Yeah, absolutely.
The application
simplification.
The application and service model is there, but it's powerful, and a lot of people don't need that power and that complexity. So it's kind of like it will always be there. It's not going away. It's layered underneath the YAML JSON resource model, but I wouldn't start there for most new development.
Yeah, if you're doing something new, I definitely start there.
And there's a lot of things in the manifest model that are actually there that you don't need or that you don't use, and you might be able to transition to the resource model just to get the simplicity.
And hopefully you can. And the point of doing that, and we kind of recommend, at least at this point, to start looking at it if you ever intend to run in the mesh environment, because you'll need to do that to run in the mesh environment. And the reason for that is that manifest model gives you a lot of low-level control, which isn't allowed in the mesh environment.
Right.
So there you can do things like, run my process as system and then mess with the registry. And so we don't let you do that.
In that shared environment, that's not going to be a thing.
Yeah. So it's not going away anytime soon, but I think a lot of the future investment will be geared more towards the resource model, and that's years out, of course.
Yeah, I think that they're going to be there forever, and that's fine.
Yeah, so there's no need to panic.
I would honestly evaluate whether or not you can move to the resource model, because it is, I think, a better, cleaner model, unless you're using the crazy advanced features of the manifest model. you can probably represent it in the resources model just fine. And that helps you with that portability.
So let me get to your second question. Thanks for asking these, by the way, Oliver.
These are good.
It's a good opportunity to talk about some of this new stuff that I think people are interested in. So your second question is the deployment JSON and mesh reminds you of default services from the XML manifest model, which you thought was an anti-pattern. And you're right, that is an anti-pattern. However, it's not quite default services. So here's the key difference between the resource model and the manifest model. So in the manifest model, those manifests are meant to describe types, application types and service types, which is kind of like a class definition in an object-oriented language. And then once you define the types, you can then later call those PowerShell commands like new service fabric application, new service fabric service to create instances from those types. So what you're defining in there is just type definitions. You're not actually defining how the end result will run. So you don't define like the number of replicas you run with or the number of partitions you run with. You're just kind of defining, you know, here's something that I can then instantiate later and then provide parameters to. Default services is weird because it puts some of the instance level information, mixes it in with the type, and that gets a little bit confusing and kind of gets weird in some circumstances.
So let's say I go and I want to change one of those parameters that I fed into the default service. So I upgrade the application type,
which
and then
changes the instance.
And then
But then I can change the instance later with an update.
Well, and what happens if the upgrade fails, right? I mean, like, so then it doesn't roll back. It just makes everything very
weird. I add a
weird.
default service and I do an upgrade, and then what happens? If
oh god.
I don't know. Okay, so it's a whole thing. Yeah.
We have a flow chart.
Yes.
Yeah.
So that's a whole thing. With the resource model, we were looking at simplifying all that, so you don't have to think about types versus instances, and so everything you deploy, everything you deploy with a resource just describes an instance, and so there are no more types, and that means there's no more provisioning step either. So the resource just says, here's the container image I want to run, and here's all the parameters for how I want to run it, and that's an instance level thing. And every time you deploy a resource, you can change those parameters to run each instance differently. So you don't have to think about the type concept anymore in that resource model. That's the difference. So it's not default services. It's maybe what default services aimed to do originally, but didn't quite get to. That's maybe.
It's kind of what we screwed up when we made default services. What we should have done instead of default services is have kind of like the mesh model or the resource model exactly is, where you have a separate document that describes the instances of the thing that you want to create, and then you would give that to Service Fabric. That's what we should have done. Instead, we already had 2 XML documents, and so we just kind of, instead of creating a third one, we jammed it into one that already existed. And unfortunately, that was a mistake, and it confused all sorts of things.
Yeah. So right now in the manifest model, when you want to run an instance of a service, you actually do it programmatically. Like you run a command and you provide all the parameters that you want to run. In the resource model, you do it declaratively. You put all that information into a file, and then you deploy the file. And so default services was kind of a mix of those two. Didn't work out terribly well. Okay. Third question. You want to take this one?
No.
No.
How do you solve a problem like actors?
All right. So from the previous Q&A, see, I wasn't at the main one. That's so the question was asked about reliable actor support in Mesh. Not terribly confident in the outlook for actors in Mesh. Yeah. So
this gets into
this is an interesting one too.
The whole thing about Mesh that's interesting is that we've taken a bunch of things and we're doing them for you, but that means that you don't have access to some of the stuff that you have in, say, a standalone Service Fabric cluster or a cluster hosted in Azure today. And one of those things is you can't just in a shared environment interact with the system services randomly, right? You can't resolve any random service in the cluster. You can't know about nodes. Those things aren't there because showing you those things in a multi-tenant environment breaks that abstraction. So the whole point of Mesh is that you can't see these things, which is all well and good. But now you run into this problem where we gave you these APIs previously that let you talk to the system services. And one of those main APIs was resolve, where you can resolve, the location of this other actor or the location of this other service. So in the Mesh environment, you have this problem where the cluster is shared, and what do we do about resolve? What do we do about a bunch of APIs? But resolve is one of them, right? And so the actor model in particular, because it's bound to that resolving a random service and then talking to it pattern, and it has that RPC model and it abstracts all this stuff from you, it's kind of hard to make it work in that shared environment without doing some surgery or resource control or security on what services you can resolve. The services model that Actors is built on doesn't have exactly the same problem because you can substitute out the transport.
Yeah, it does a lot of
The resolve
problems,
API
though.
itself still has the problem, but
Yeah.
you can get a services model without the transport. Whereas the actor model,
true.
you're welded.
Yeah, it's true, yeah. But you still have access to this runtime, and the runtime allows you to do things like get information about the node you're running on.
Right.
So none of that's available to you in a mesh environment. So in the mesh environment, you're still running C# code. You can still do whatever you want in your C# code. You can still use whatever transport you want. But because it's a shared hosting environment, you can't get a free-for-all access to the low-level cluster APIs and then to the service discovery. Because I could get deployed to mesh, and then I could go look for Matt's application and delete it.
Right.
That'd be
good.
fun, but that'd be bad.
Jerk.
In general.
Yeah.
So that's why it's hard to get the existing reliable services and reliable actors into that environment because of the level of access they require in order to function, which we won't have in the mesh environment. So we have to work through all of those points and try to figure out what to do about them. The model itself can run. It's just the access it needs to the underlying system is going to be limited. So we have to figure out what to do about it.
But part of that, so a second part of the question is like, does this mean that like I'm going to lose all these programming models, or that I'm not going to be able to carry this stuff in the mesh, or will other programming models not show up, or whatever? The goal is to give you equivalence. So you've already seen the work where in reliable services, one of the main things that people used, and that has kind of the same question, is the collections. So we have these reliable collections. Well, today the reliable collections are bound to that programming framework, right? You have to derive from stateful service in order to use the collections. So if I can't derive from stateful service because I can't give you access to all those APIs that don't make sense in the mesh environment, how do I get to use the collections? And so we went and did a bunch of work where we broke the collections out. We made them a library that you can include in, you reference, and then you get the same capabilities that you had previously, but it's in a separate, kind of more scoped package so that all you see is the collections, and that's what you need to worry about. You don't get all the other stuff in the runtime that you don't need, and some of which doesn't work in the mesh environment. So we're working on those types of changes to make all the programming models that we have make sense, or in some way convert them so that they can work reasonably in the mesh environment. But it is a lot of work because the scope of Service Fabric runtime APIs is actually quite broad. And so figuring out how to carve out the parts that still make sense and leave behind the parts that don't make sense or that wouldn't work in a mesh environment is the work that's ongoing. It's in both programming models. It's not just actors, but that's the work that's ongoing, and that's part of why there's hand waving around the duration of how long it's going to take us to sort everything out. We got some work to do.
Yes.
So hopefully that answers it.
Yes. So your next question is also a good one.
Yes, it is.
So this is a pattern that is pretty common in Service Fabric today, which is you have a multi-tenant system you're running, and then for every tenant, you spin up a new application or service instance just for that one tenant. And we use that a lot internally as well. So the question is, if you do this on mesh, is it going to be crazy expensive because every service instance you spin up is a container and you have to pay for the resources allocated to the container. So yeah. And then what do you do then? Probably.
The answer is going to be it's probably going to be expensive.
At least at this point in time, that will be the case. Every instance you spin up will be a new container. We don't have currently plans for a shared hosting model the way we have today.
Right.
It is, of course, something we can change and we can look into. But at this time, yeah, it's basically as you described. It'll be a new container instance per tenant. For every service instance that you spin up will have its own set of containers.
Every single post, every single resource you put in there is an instance. And the container has, the resources that you wanted to give to it. So this container wanted 2 cores and a gig of RAM. It gets 2 cores and a gig of RAM. So when you post another one and you say, I want another one with 2 cores and a gig of RAM, that one also gets 2 cores and a gig of RAM. So you can make those resource requirements smaller, right? That's one way to get more efficient running. But there's nothing that says I want to create multiple service instances inside of this thing. That's just not something in there, and that's kind of related to the programming model question, which would be if we let you do this, how do we describe it, and how do we make that work in a world where we're not letting you see most of the runtime? This is one of those trade-offs where people are going to have to do the math and see whether or not the mesh environment is worth it for them. What you're getting is that serverless environment, right, where you don't have to run machines, you don't have to deal with the cluster, you don't have to deal with scaling. A lot of this stuff is automatic, right? But you have to remember that all the capabilities that we talk about are not mesh specific, right? There's basically nothing in mesh that is not in the core product. So you can have the resources model, you can have the secret store and all the other stuff that we're talking about in a Service Fabric cluster that you run, and that lets you have more control over how things get placed and whether or not things are co-located, whether or not things are stacked in the same process and all that stuff. So the whole point of mesh is just to take the cluster management away, take that infrastructure management away for people who don't want it or need it, right? If you don't want it or need it, today that's a huge barrier to entry for all sorts of people. And we find that getting rid of that is going to make it easier to start using some of the features of Service Fabric without having to worry about, managing my VMs, which is not a part that people generally enjoy. But you're right, in order to do that, you have to give up some power. And that power might be something that you're using, and we're not gonna force you, right? I mean, you can always just keep running where you are.
I do think this scenario is an interesting one and a pretty important one because that is something that a lot of people do today. So I think it's something we need to dig into a little bit more and figure out what would be a good way to enable you to allow to keep using that pattern.
We also got to keep in
the same
mind,
APIs, but this
we're still a couple weeks out of nailing down pricing as well. So
Yeah.
it's not an
Yeah,
apples to apples thing right now.
Right.
Yeah, that's something we definitely need to concentrate.
Yeah, I mean, we are just getting the preview out the door, so a lot of this can of course change, and I think this is one pattern that we'll keep our eye on and make sure that it's still at least feasible and affordable.
Because this is a core thing that people do with Service Fabric that is also really hard to do with other systems.
Exactly. Yeah.
So we really value this scenario, and we're going to figure out how we can bring it to mesh. But in the meantime, all the capabilities are just in Service Fabric, the core product, so you can always just use that. And not have to give up that control and power and that efficiency that you're getting.
Okay, so let's move on. Number 5 in the list. So is there a mesh equivalent for programmatically spinning up a new container and communicating to it? For instance, in traditional Service Fabric, I would just call it
Service Fabric.
I use Fabric Client and Service Proxy for moving message up. Yeah, so all that stuff will be possible. It'll be a different set of APIs, but the same way that you say, Fabric Client, create new service or create new application today, you'll have the equivalent, which will be deploy a new service resource or a new application resource, and that'll effectively give you the same
Programmatic.
result. Yeah, it'll give you the same programmatic result.
Yep.
For communication, so instead of using Service Proxy, of course, we'll probably look towards just direct communication between services. So this is also kind of a difference that we're aiming for just in the resource application model in general for Service Fabric, where your services communicate with each other just using their well-known DNS names, domain names, which are automatically generated when you deploy the service. So it's just the name of the service. So service.myapp or whatever it is. And by communicating directly, if they're just stateless to stateless, then it's just a DNS lookup. You can use whatever protocol you want. If you have more complicated routing requirements, there will be an underlying networking layer that kind of routes calls for you. So traps network requests, sends it through a proxy. Proxy does a lot of the hard work of service discovery and any network level details that you generally want to keep out of your service code anyways, like retries and circuit breaking and rate limiting and all that. That'll be controlled at a lower networking layer, which then you can configure through another set of resources, basically routing rules that you can deploy. So it'll be better in a couple ways. So for one, you're not limited to just one language. You don't have to do everything in C#. You can go across languages. And the second is that you can, in general, bring your own protocol too. So it doesn't necessarily have to be a remoting protocol or anything like that. You can just bring whatever you want. So you can bring HTTP or gRPC or whatever. Some of the higher level features will light up for certain protocols like HTTP, but you can always just do DNS and bring your own protocol. All right. Last question's a controversial one. Oh,
well, we'll see.
All right.
All right.
At least it says it's controversial.
Well, it's not
thanks,
that controversial.
Thanks for the warning.
Yeah.
Is it about T-shirts? That's the last one.
Yeah, that's the last one. That's the easy one. He gave us a deep T-shirt.
Softball at the end.
All right, just call him.
Yeah. Find Deep on the internet.
He'll do what he needs to do.
You have to tweet at Deep.
Just tweet at me.
That's the only
Tweet
way.
at Deep.
Yeah, I'll get you a t-shirt. Just tweet at me.
That's how I get T-shirts.
He just tweets at me. He literally sits behind me and tweets at me. It's
Yes.
unnecessary.
Yes.
That is totally unnecessary.
I'd have to turn around.
Oh.
Yeah. Not my
That
jam.
wastes too much
Let's do the
time.
controversial one.
All right.
Controversial one is fun.
Is Mesh a response to an industry that is massively shifting towards containerization, which has meant Service Fabric needs to pivot to not get distance from where all the container fun is happening?
So let's stop at that part.
Start there, yeah.
No, because Service Fabric
is the opposite.
Yeah, the main thing that Mesh is in response to is the fact that managing clusters is hard, and nobody really likes infrastructure. Unless you really need to manage the infrastructure, nobody really wants to manage the infrastructure. So it's the serverless trend is the one that Mesh is kind of targeted at. And the fact that, again, I don't really like dealing with OS patching. I don't want to deal with setting up the networks. I don't want to deal with, VM scale set, auto scaling. All that stuff was overhead. I want to write my service. I want to run it somewhere, right? And I don't want to have to deal with all this other stuff. So Mesh is an attempt to get all of that infrastructure management out of your face so that you can focus on, writing, deploying, and managing your actual applications, right, in an easier way than what we kind of give you today. So since this kind of goes back to containers are in the core product, right? Containers are everywhere.
Containers are everywhere.
So we did that already. That was already in the pipe. And Service Fabric, even though this is a general problem that Microsoft had, I think, is that Microsoft had been doing things like containers for ages, right? SQL is effectively in a container. It's not a Docker container, but it's got it's statically bound. It loads up and limits resources. It's got isolation from all the other things that are running on the machines. So we've been running things like in containers for a really long time. The container part isn't new, and there's already parts of Service Fabric that have been going towards containers for some time. So Mesh isn't about that. Mesh is about that serverless environment and getting the infrastructure management out of your face.
Yeah, and actually I'd say it's even more the opposite. It's not even moving to containers, but starting to move away from containers. So the fact that your application runs in a container should ultimately be an implementation detail. Because what you're deploying is an application. Containers are still infrastructure. It's a slightly higher level of infrastructure above VMs, but it is still kind of infrastructure. You have to load up a bunch of stuff in there. You're basically creating an environment for your applications to run.
And as you mentioned in the other part of his comment, you have to learn this stuff,
and
right?
You gotta learn this stuff.
Now I have, I joke always that, the world had just gotten things working with virtualization, so then we broke it by adding another layer of virtualization.
Yeah.
So now we have to learn how to manage these things. We have to patch them.
But now it's even weirder because now your application is coupled with some level of infrastructure inside of a container. So the application developer is now responsible for patching the container image.
Yeah.
I mean, that it gets a little more complicated. Really, what you're trying to do ultimately is I just want to deploy my application and make sure it runs.
Right.
That's
I want to isolate it from the other guys, mainly for some level of safety for myself, but also to make sure that it also keeps running.
Yeah.
Right.
So containers to me feels more like an infrastructure implementation detail that you shouldn't have to care about.
Yeah. And hopefully that'll continue to become more true.
Exactly. Yeah. Ultimately, the orchestration of containers will kind of be an implementation detail underneath an application layer, which is where you really want to be, where you just deploy applications that run in your environment, and then you're set.
And to the other part of your question, right, that's also why we're still very much invested. Service Fabric, one of the main value props of it is that it has these programming models, which you make good use of. So the goal is to try and get as much of that programming model goodness into a Mesh environment so that you can continue to do the things that you do today, but in this shared environment. And again, the only reason that it's not automatic is because those programming models today give you access to all sorts of the runtime stuff, which is now in this shared place. So that's the work that we have to do so that you can get the best of both worlds, right? You can get the infrastructureless environment where you just get to deploy and manage your application, and you also get the programming models for the productivity of writing, things that are actually going to scale and work well in that environment. You get both worlds.
And so the next part of your question here, where you say a lot of the stuff they get for free, like programming models and packaging and such, none of which seems to be a focus in Mesh so far, and that's partially true. Right now, that isn't our focus because we have to build up the hosting environment first, but we're doing it in such a way that we can then light those things up later.
Yep.
And light them up in a way where it works nicely in a shared environment and where you don't have to manage the infrastructure. So that will eventually come later, and we're thinking of ways to do that also allows you to use multiple different programming languages to accomplish that, and also run those same applications outside of a Service Fabric environment as well. So we're trying to give you the same, basically that same feature set, but without locking you into the Service Fabric product necessarily. Right. So you'll be able to write polyglot services, any language you want, without actually feeling locked into the Service Fabric product.
And I think that there's a whole bunch of things that still commend Service Fabric or Service Fabric Mesh that are major differentiators from other platforms. We have long-standing support for Windows and .NET. The nodes are self-healing in the sense that if they fail, that your workloads just fail over somewhere else automatically. We can automatically upgrade your clusters for you. We can span across multiple AZs. We can do private networks. We're going to be shipping
pretty awesome Visual Studio tooling integration.
Yep, the tooling's there. Azure Stack support's there. We're in the sovereign clouds. Like, there's all sorts of stuff that's different about Service Fabric in general that will be present in Mesh as well. That are major differences between Service Fabric and Kubernetes or anything else. So
yeah, I think the big difference is just in the way that you consume the programming models that we do provide.
Yeah.
So, I mean, today it's a framework that you kind of get locked into, which if you're only ever on Service Fabric may be okay, but if you want to remain somewhat portable, then that can present a problem. So it's just kind of flipping that around. So you consume them as libraries and packages that you can inject into your applications through dependency injection. Use more standard frameworks and APIs that are available elsewhere, and allow Service Fabric to kind of light things up underneath you. So the
environment is better.
The environment is better, right? So like the typical example is you might be running an ASP.NET application that uses, say, a distributed cache, session state, or SignalR or something. If you run that outside of the Service Fabric environment, you have to set up some storage accounts, databases, something to help manage where that state gets put when you're putting something in session state or in distributed cache. If you take that same application, don't make any code changes, deploy it to Mesh, then you get the data layer underneath you for free, and you don't have to stand up those databases to manage your distributed cache and session state and SignalR and so forth. So you can take the exact same application you have running elsewhere, run it on Mesh, and things light up and run better. That's kind of the plan. So you get a lot of the same functionality, but in just kind of a different way.
Long question.
Okay. All right, we're done with one question.
Okay, Oliver's blown his question quota, so that's
You're done. You're out.
You're out.
Good night.
Good night. Have a good day. And we're on to the next step. So Marcin wants a support matrix for all these different things. For the most part, everything is supported. The only one that might be weird in there is Docker CE versus EE. I think that's the only thing that's a little weird between. That's mainly also dependent on what OS version you're running on, because Docker EE is like auto included in server, but doesn't really work on your dev box or your local machine. And that's also where I think when we mentioned like the local loop of debugging and getting that VS tooling to be really humming, that F5 experience with containers is still a little rough. I know that we've done a lot of improvements.
It's actually really good in the new stuff.
Yeah, the new drops of toolings are finally getting there.
Yeah, they're actually pretty sweet. They're really fast.
Yeah, but that's been mainly the hiccup, is the interaction between Visual Studio debugging containers and Windows has made that matrix seem maybe more sparse than it really is, and more complicated. That's all getting resolved. I think, did we already do that release? Is that new drop out, the container tooling?
It's in the, I think it's in the preview.
Okay.
But the matrix is a good idea. I mean,
it
would be helpful.
I'm just saying, for the most part, it's checks. Right?
It's checks.
It's all supported. But it'd be good to say.
Nice to have.
Yeah.
Checks.
So I think it's
we don't have anything like this today.
Thank you.
We do, but it's scattered in a bunch of places.
Okay.
And
It would be good to consolidate.
pulling that all together would be good.
It's easier to get like where we're supported in terms of OS as opposed to knowing what features light up in what OS. So.
Marcin wants to know, can we call the XML manifest model Service Fabric native? No.
No.
Also not classic. Anybody that does that, I mean,
Native implies C++ and C.
yeah.
Which that gets confusing too. Because when we say native, people are like, oh, it's that program in C++.
We're going to call it what it is, which is the XML manifest model. It's a bit of a mouthful, and that's because we're bad at naming things.
But it's descriptive.
Yep, but it is what it is. So.
Oliver's +1 doesn't count. You're already done with your quota, man.
Jeez.
I would like to advocate a bit for the native, because native doesn't mean C++, it means that you can leverage every capability of the underlying platform. So I would really like the differentiations of Service Fabric Native and Service Fabric Mesh. Service Fabric Mesh is nice to focus on your applications, and Service Fabric Native allows you to leverage everything that the platform can. So this is my suggestion that can help to avoid all the confusion that was we could observe in the first question. Yes.
Okay. Okay. I noted. I like where you're coming from. Yeah. I like that idea. Yeah.
It's good feedback, Marcin.
Your next question is, what is external ring? It is nothing as fun as what you're expecting. For the most part, it was an attempt at that once upon a time, and then I think all it means today, or all it does today, is the external ring is the part of the ring that is not my local neighborhood, as far as I can recall, is what we ended up using it for. But I wouldn't worry about it. Especially when you get down into the Federation stuff, keep in mind this code is like 10 years old and we didn't know what we were building then. So some of the names of things can be quite misleading relative to what they actually do. But yeah, as far as I know today, it's for your non-neighborhood nodes and figuring out what part of the cluster you're in.
We're also going to do some more deep dive videos for the Federation starting in the next couple of weeks. So
cool.
If you have any questions specifically for that, Marcin, feel free to get in touch with me.
Yeah, that's a good one. See if my recollection is correct.
Yeah. So we'll talk to Lou and a couple of the other devs that actually wrote this, and you'll get some more info.
And then the question is, what is the vote type? This again is old dead code. When we were building Service Fabric initially, the Federation didn't work, I think is the short way of saying it. And so we needed some place to put the votes for the seeds that were not the cluster, because the cluster was not working. And so we did what you do when you're bootstrapping anything, and we wrote a shim, and we stashed them in SQL, or we stashed them in a file. And then eventually the Federation actually worked, and seed nodes worked, and all this stuff actually worked, and so we got rid of it. So there's no actual way to turn that stuff on that I'm aware of. That's more dead code, as far as I know. We've never put that back in. It's just kind of sitting there. So you're spelunking through the geological ages of Service Fabric and finding some cool stuff. But yeah, that's the vote types. So none of that stuff works, as far as I'm aware. Everything today, the seed nodes are the votes, and the votes are all in the cluster. Some questions from Joseph. Cool.
This is an interesting one. Yeah. So
Okay.
a couple .NET Core SS services when they're packaged. They're 70 megabytes each, which is massive. And so your whole application package is over a gigabyte. I think the solution to that is what they call the Runtime Store in .NET Core.
Yeah.
So that's a way that you can deploy all those dependent libraries ahead of time to the environment in which it's being hosted. And I'll send you a link to that. So it's I hate to say it's the GAC all over again, but it's kind of like GAC
It's
core.
kind of like the GAC.
Yeah.
They realized they had this
awareness.
problem to address exactly what you're dealing with, which is, how do I patch something in one place? How do I share these libraries, since they're all the same, so I don't copy them hundreds and hundreds of times on the machines, because they take up space. So that's what they invented this thing for. And there was also like the concept of whether or not you carry the framework with you as a part of your service, or whether or not you expect it to already be in the environment.
Yeah, there's kind of two layers to that. So you can package up the entire .NET Core runtime with your application. That makes it really big.
But very self-contained.
Very self-contained, but and then you target a specific architecture and operating system. So you can make it neutral to the operating system and architecture if you have the .NET Core runtime installed on the target machine first. And then you can go a step further, which is for the framework that you're using, like the ASP.NET Core framework. You can have the framework libraries already pre-installed on the machine as well, and that's the Runtime Store that I was talking about. So I put a link into the chat window there. Check that out and see if that helps bring the size down. So your next three questions, I read over these. These are very, very detailed. I don't think we're going to be able to answer these in the room. I would recommend going on to the GitHub repo for actors and services and open up issues for these so we can get those answered.
Those are good questions.
They're good questions, but they're very detailed. I don't have the answers.
Yeah,
off the top of my
the
head.
service event source stuff also makes me a little crazy.
It does, yeah.
I think you're not alone in that
I
one.
don't know if there are side effects from generating that using emit.
We're also
Never
looking
tried
into replacing that with iLogger for the .NET Core stuff.
That's true, yeah.
Over time, so hopefully that also compresses the package.
This feels so good. This is one of those things that kind of goes back to Oliver's questions around like changing the frameworks and the models that we give you to be less Service Fabric specific and more using the common patterns
Standard
and stuff that's already there. So things like iLogger, things like ASP.NET Core's configuration mechanisms, stuff like that. That's a big part of what we're trying to get to, that hopefully makes a lot of this stuff go away over time. But yeah, Joe, I would say open those up, and we can make sure we get those addressed.
Well, I'll drop the link for you in the chat, so just not
Yeah.
do that.
Okay. Question from Gregory. Process of migrating from Docker Swarm in production to Service Fabric and run into a bunch of limitations for container orchestration in Service Fabric. Single instance deployment model composed type versus current deployment with a bunch of XML files. Will Docker service update be supported? So I think we did do upgrade, but I don't know if that's the same as Docker service update.
I don't know.
Yeah.
I don't know.
I'd have to go check. Our goal is to get to parity for all of these things. I would have to look more into what that one specifically is. Unfortunately, I'm not as familiar with Swarm and some of the things that it did. Generally, we're just a wrapper around like Docker-D, Container-D, and so the goal is that anything that it supports, we will give you some knob to do. There's already ways to pass through commands to Docker when you start the actual container. So anything that it supported, basically Commandline Arts, should be possible in Service Fabric today, even if we don't have a first-class way to do it in the XML model. If you're having specific problems with that, I would say you can reach out to me, or you can open up an issue on probably the main issues list.
I think you did.
And there's one of those?
Yeah.
Dynamic environment variables, yeah. That
So
one's interesting.
so 2, 3, and 4 are kind of interesting because the work that we're doing now for the resource-based model actually
Solves all this
answers
stuff.
all of these. Yeah. So the resource model gives you something that actually looks a lot more like Docker Compose, where you just have a YAML file or a JSON file. It says here's the containers I want to run, and then you just deploy that file. So you don't need the help of Visual Studio to create an application package and then provision the package. You can just send the file through command line to your cluster endpoint, and it'll spin up your containers. So that's the simplified deployment model. You'll be able to do dynamic environment variables in there as well, so all those things will be overrideable. And secrets is another big area of investment for us. So we are shipping a secret store service, and this is a way for you to store keys, passwords, secret values, certificates. For certificates, it acts as a broker between a cert store like Key Vault or something else on-prem where you get hardware level encryption for those. The secret store will take those values out of Key Vault or whatever store you're using and then mount them for your applications to use. So it'll ACL them to an application identity, give the application access to it. When it's running in a container, that just means mounting a volume. So you basically have access to those files on disk. For secrets, you can get those plugged in through environment variables and access it that way. So it's kind of the standard way of doing things, just using operating system primitives instead of proprietary APIs.
Yep.
If you're doing ASP.NET Core, .NET Core, they actually have APIs wrapping those mechanisms, so it makes it even easier to pull secrets out. And so that'll all just kind of work once the secret store lights up.
And today you can do secrets, but it's painful.
It's self-encryption today, so you have to encrypt the secret first with a certificate, inject that ciphertext into your application, and then you have the certificate again installed on machines that's running the application, so then you can decrypt them back. So there is a way to do it, it's just a little bit painful today. So that'll be a lot easier with the secret store, which will kind of take care of that stuff for you. If you're running in the mesh environment, it's even easier because everything you need to do encryption, decryption, and manage service identity is there as well. So that should become super, super easy once that becomes available.
Yeah.
The Active Directory question.
Whose credential is this?
That one I'm not sure.
That should be a parameter. I don't know why it's a
Yeah.
switch. That's unfortunate.
Yeah.
So I think, today you either have to impersonate or you have to get them some other token that, in order to deploy it, it's interesting. So you're using actually Windows credentials to authenticate to the cluster. That's harder. So I would maybe move to a thing where you're not using the Windows auth or the AD credentials to authenticate to the cluster for the purposes of deployment, and that should alleviate some of that. The downside is that now you're stuck into like AAD tokens or cert environments, which are also painful to work with. If you have an issue or open up one for that, we can try and figure out how to make that more parameterizable, so you don't need to really bifurcate the environment like that, or figure out some other way to set up the environment. I presume that this deployment is coming from VSTS. If it's not, then that's another thing that we can try and figure out how to work with whatever that build system is. But I think that's an interesting scenario that we should make a little bit easier. Okay.
Deep. This one's for you. App Insights.
when an
Yeah.
SF instance is
Oh, yeah.
provisioned, you can specify an app insights key. So currently, no, because the app insights key is part of your when you build your actual application and you push it, it's passed through as an environment variable or as a parameter for your application. We are looking into dynamic reversal of that or change of that or enablement of that. So what that means is we're investigating how in the future you can deploy an application and then after the fact be like, oh, I want to enable application insights. How can I do that to a running application? So we're looking at that right now. It's obviously a little bit tricky, as you can imagine. It also gets a little bit harder in the container world. So we're trying to figure out what a good way would be to do that. But right now, the way it stands, you'd actually have to modify your application insights instrumentation key and then do an app upgrade for that to actually pass through and modify the AI resource to which your telemetry or your traces are going.
So you can do it after you deploy the application, but you do it
Yes.
through an upgrade.
Yeah. So it is doable, and we're trying to find a way to make it even easier to do. But right now, the way you do it is through an upgrade.
Cool. And then he points out that, what's it for? Because today you still have to go do work to make your actual stuff show up.
Yes, yeah. So the reason for that is if you look online, some of our samples basically allow you to propagate the same AI key across all of your services. So by providing it in one place, you can actually use it as a set variable that applies to all of your services. We're trying to improve the tooling for you to only have to do that once for your entire application as opposed to having to enable it on each service. And that's kind of our stepping stone to then being like, how can we auto-enable it for each application? So the first thing actually that we're doing down that pipeline is making sure that the app insights NuGet for Service Fabric is stable and works without too much of a hitch. So the next version that you see coming out on that front will actually no longer be preview. Once we're happy with that, then we'll move to improving the tooling around it, and then we'll improve the experience in terms of enablement. So that's sort of a sneak into the roadmap there.
I guess to follow up on that then, does that mean that it's going to be a little bit easier to implement app insights in stateful and stateless services that aren't running ASP.NET?
Yes.
Because I guess right now that's a bit of a
It's
pain.
hard. Yeah, it's extremely hard. ASP.NET Core, especially for actor services, is just a giant gaping hole right now. So we are plugging those things, and we're going to make sure we do that because we want to have a good experience on that front. It's very important to have easy diagnostics for your application. So we're working on that. We're also trying to do as much telemetry and auto data collection as possible from your application. So one of the reasons why we're moving Dialogger for a lot of our actual templates that generate stateful services is because that plugs directly into the App Insights pipeline without you having to do any plugging or replugging.
Yeah.
So we are looking at that for sure. We will continue to improve it. So keep a lookout for the coming maybe couple of months. Hopefully those improvements should vastly improve your experience.
I think at this point it's fair to say that we're getting very, very friendly and very close with the App Insights team.
Extremely, yes.
Yes.
Maybe too close. No, I'm kidding. Yeah, it's a good time.
Yeah, we're aware that this is harder than it should be. There's other things that we've been doing in the kind of telemetry space as well, the event stuff.
Yeah, the event
Also
stuff. Yeah, I don't know.
It's not strictly related, but it's a primitive form of the kind of stuff that you get out of an App Insights app level tracing. So that's the diagnostic events where we're finally publishing in the cluster the events that are happening to your service. So if the service moves or we shut it down or it crashes, we put it over here, or we load balance it over there, you're going to see a diagnostic stream in the Service Fabric Explorer about the events that have happened in the life cycle of that service. And that should also help you build, debug, manage, understand what's happening in these environments. It's primitive, but it's
also meant to be not too extensive because the goal is effectively point in time. Can I see the status of everything? What's happened leading up to this? Can I
give me the last few minutes?
Quick and dirty.
Yep.
Yeah. Yep. So
is there any chance of being able to get that to push into App Insights as well? Mainly so it's just retained.
It's the same data store.
It's the same, yeah. So we're just using our the Service Fabric events that are published via the ETW provider. So if you just hook in, the way to do this would actually be to use the event flow NuGet, which has a input source for ETW traces and has an output for application insights. So you can effectively just use event source, modify the ETW trace to pick up the particular provider that we require with which we're publishing the Service Fabric events, and then just route that to your App Insights resource. It's actually quite trivial. We have several samples of this. If you want a specific sample, let me know. I can find one for you.
Or find one now.
Yeah,
Just dump it in my window.
Yep.
So next question.
That's from WIT as well.
Yep.
AMSS?
Yep.
Yep. So when VMS scales up and then scales back down, the node state remains and it sits there until you delete it. Yeah, so what this is, first of all, I'm going to go ahead and say I know that VM scale set is configured with durability level bronze. And the reason that I know that is because this is where that happens. Bronze is when there's no integration really between the management of the infrastructure activities that Azure does and Service Fabric. So when Azure adds VM scale sets, or adds VMs to the VM scale set, those just look like new nodes come up, they're configured correctly, and they join the cluster and everything's great. But the interesting part is when it takes them away. And since it's not telling Service Fabric that it's taking them away, Service Fabric just thinks that those nodes are down. They just crashed and they're down and maybe they'll come back. And by default, we don't know that they've been like permanently removed. So Service Fabric just sits there and goes, well, I had node 7, but it's not here right now. It must be down. So until something, in this case view, comes and says, hey, that node is actually gone, it just sits there in the records. So you can continue to do what you're doing. There's a document called programmatic autoscale that you can look into to kind of take control back and do things directly. Or you can change that VM scale set to be anything not bronze in terms of durability. And what will happen then is that Azure is going to start kind of broadcasting the changes that it's making into the cluster, and the cluster will notice them. And then when it takes the node away, Service Fabric will know that that node is gone because it received that information that the machine's actually being deprovisioned. And then the node state and everything will get cleaned up automatically.
Great. So moving this to silver would just solve that?
Yeah, it absolutely should. I mean, there's pros and cons to silver. So some operations. So since basically what silver does is it makes Azure start asking not quite for permission, but at least awareness of the cluster that these things are happening. So if you're scaling up and down, rapidly, Service Fabric will actually slow that down because we're going to make sure, for example, that taking that machine away is safe. So we'll migrate all the workloads off of it first. As it is with bronze, Azure just comes and rips the plug out, and to Service Fabric that looks like a failure. So we're reacting that way today. What will happen instead is that Azure will come and say, hey, I'm going to take this machine away, and Service Fabric will go, oh, hang on there, I'm going to move all this stuff out first. When you see, if you go to the managing the cluster thing where we talk about the durability levels, you'll see that there's a time associated with these operations. Basically, that's how long Service Fabric can push back on the operation before it just happens. So Azure is going to go and take that machine away. If you tell Azure to take the machine away, or autoscale does, that machine's going away, and there's nothing that we can do to stop it. We can delay it, though, and what this does is lets us make sure that it's safe for the application, safe for the services, and everything's healthy before we let that machine actually go. So if we went to take that, we went to move that service somewhere else, and it wasn't responding, or it was slow, the machine doesn't go away until that's done up to a point. And that's what the different durability levels kind of give you, is how long can we delay that operation. So anything above bronze gets you that integration. And the node states will go around, get cleaned up automatically, and we'll be making sure that the operation is actually safe for the service. And if you want to talk about something that's a benefit of mesh, it's this. You don't see this anymore.
I was going to say that was a very good answer to the earlier question of why are you building mesh?
Yeah, what's mesh for? The mesh is for not dealing with this.
That becomes our problem.
Yeah, you want it to kind of be our problem.
Yeah. So general question about just when will Envoy proxy be released as part of Service Fabric? So this it's coming in a few parts. The first thing that will be lighting up fairly soon is just the ingress portion of that. And that's a replacement for any time you've ever had to write a stateless gateway into your
or use API management, or deploy traffic, or traffic. We're hip.
So that'll come first, and then later we'll get into the actual service-to-service communication, and that was the underlying network substrate that I talked about earlier, where the proxies intercept network calls. So expect that later in the summer is when the ingress side should show up.
Okay. There was a bug around a memory leak. Yep.
Yeah.
We know that one. I should actually go and mark that as bug. I'm pretty sure that it's been resolved and deployed internally at this point, but I'm gonna track it down so I can do that. So that's fair.
So is it possible to compile against any CPU instead of x64? Yeah, so our libraries that we ship, the ones that I was talking about earlier where they kind of lock you into the Service Fabric frameworks, so all of those libraries are x64 compiled. They're only x64, so that's why your applications also have to be x64 compiled. The feature that we're kind of moving towards, it should give you a little more flexibility to compile against any architecture or against any CPU if you're in .NET. The libraries that you pull in those circumstances, whether those are x64 only is still TBD. I think it's pretty likely they will end up being x64.
Yeah.
But at least in that environment, if you're not taking a dependency on Service Fabric library specifically, and you're just using our HTTP APIs, then of course you can compile against any architecture you want or use any language you want. And so the goal there is just to make that world a little bit easier. So today we have a separation between guest exe, guest container, or a reliable service where you take a dependency on a framework. All of those different options kind of require you to define your application in a different way, or define your code packages at least in a different way. And so a unification of that is what we're looking for. So it'll all kind of feel the same. But at least for now, that's why you have to do x64.
Yeah. It was a decision we made a long time ago that we thought x86 was going away. We were wrong.
I guess it hasn't yet.
Yep. We were a little bit premature on the death of x86. Whoops. So we made a decision to make everything strictly x64 a long time ago, and it's kind of baked in at this point. It's good for some things. We have a lot of memory mapping and things like that actually happen in Service Fabric, but it was probably, especially for the client side APIs and the bindings that your code operates against, it was probably too hard of a requirement.
Yeah,
so.
And that at least for the client side APIs, that is something that we can relax a little bit.
Yeah.
Mostly because the new client library that we have out now in preview doesn't take a dependency on the underlying native
runtime.
Yeah, the runtime and then the native code for transport. So it's all just .NET standard, and so that should relax that requirement a little bit. All right. Data info about stateful data available within the Service Fabric. OData. That is one of our projects, isn't it? I don't know. I wish I'm not too familiar with this one. That's the data viewer? That's Jesse's data viewer?
Yeah.
Okay.
I know we keep,
That's your data
we're
viewer.
continuing to work on it. Part of it is that, as we mentioned in Mesh, there's a lot of things changing in the data stack right now. We're porting large parts of it to native that weren't already in native. We're making the store work across different languages. And so that's changing some things about the store. And so we're kind of waiting to do the querying until the store stabilizes again in terms of taking dependency on data formats and stuff like that. To say that, we're doing all these changes incrementally, so nobody's really noticed that we're changing lots of things about how the store works. But there's been a lot of work to re-implement parts of it in a way that becomes more language agnostic. That should also make querying it easier. One of the problems that we had when we did the original state store was that we kind of baked the .NET, concept of types directly into the store. And that makes it really hard to query in other languages because you have to kind of know how .NET does things. So we could build a viewer for that, and the OData one's a good example of that, where it shims in at kind of the protocol layer. But we don't really want you to have to be bound to HTTP. We don't really want you to have to be bound to that managed version of the store. And so there's a few things that we're sorting out, which is part of why that feature unfortunately hasn't materialized. I think Deep did a call saying, contact him if we've got additional feedback.
Yeah, so we actually have somebody who's kind of working on it right now. So they're at the stage where we'd like to get some more feedback. So if you didn't see my message, please send me an email like right now saying that you're interested in checking out where we're at, and if you could give us some feedback.
I think it's finally getting back to a point where we're going to resume visible
support.
progress on this.
Correct. Yes.
That's a
good way to put it.
We kind of went down into the basement for a while and have been fiddling around with stuff, and now it's going to pop out.
We're like on the stair before at first floor. I mean,
Is this the wink wink emoji?
Yeah, this is the wink wink emoji.
All right.
Okay.
Because everybody sees this, so
Okay.
be careful.
So
May or may not.
So time check, 5 minutes left. So now we enter what we call the lightning round,
Yes.
where we try and screen through
Favorite
questions
part.
as quick as possible.
We're actually doing pretty good.
Is managed service identity feature going on-prem in an Azure unrelated way? Is there any way to authenticate requests from other services using the feature? There's some work around this, but I don't really know what that would be. I think it's also kind of the other way around. There's GMSAs in Active Directory environments, and that's kind of coming more to Azure. And so there's going to be some interesting interaction between those two things. I don't think we have a great story yet. The longer-term story is the secrets and identity stuff that we're doing kind of in general. So stay tuned. V2 serialization fails. Type data contract, blah, blah, blah. Not expected. Use data contract resolver.
Since we're short on time, would you mind going and opening up an issue?
Yeah, we should be able to make that better.
This is the same repo I linked about.
Feel free to skip mine until even the next session. I'll just re-ask them.
Wow. Okay. Easy. When is Replica Store replacing ES0 for customer services? It already has for everything new that I'm aware of.
When can we expect mixed OS clusters?
Mixed OS clusters
for a
is,
while.
that one remains the same problem where in Windows we have a dependency on a Windows kernel component called SSPI. There is no such thing in Linux, so we have to re-implement everything using SSL, and then we have to figure out how to upgrade existing clusters to use SSL without breaking the world. That's going to be a while. Multiple security modes in a rolling upgrade is tricky business.
If you'd like to do it though, feel free to.
Yeah, I mean it's open source, so Marcin, you just go ahead and.
We're not going to stop you.
We'll look forward to that PR. That'll be cool, right?
Thanks, Marcin.
Thanks in advance.
You're the man.
But yeah, we know we want to get there. Today, there's two you have to either run two clusters or there's a lot of work going on in the container world to do what they call LCOW, which is Linux containers on Windows, which might show up and be a supported solution sooner than we get true mixed OS hosts. Because of this security.
Well, at that point, even though your host might be a single OS, your actual workloads could be
your workloads or whatever.
So effectively, you're close to being.
It's close. It's not quite the same, and the Windows containers guys and the Windows container host guys are still working on that. But that's another way that you might get out of it sooner. Is the replicated store implementation somehow related to the faster implementation with this paper? I don't know that paper, so probably not. Key value store. Don't recognize these names, but I will look at this one. Oh, Justin. Yeah. Justin Lemondowski. Yeah, we know him. It's probably similar. This is like B-trees and the latch-free store and all this other stuff. I would say that it's similar architecture, but not the same. We worked with those guys at one point. And
last question here from Whit. We can get your question. We got 3 minutes. So you're using a reliable concurrent queue and you're pulling data out of that from a stateless service. Is it possible to address not using the default, but to read from secondaries? So we generally don't recommend reading from secondaries. You won't be able to make writes to secondaries, obviously.
But you can. You can read from a secondary.
You can read from secondaries, but you may get stale data, which in a queue is probably pretty bad. And then, of course, there's this wonky case where you may be reading from a future that doesn't exist.
Yeah, you're reading from what we call false progress, or you can think of it as non-quorum committed data. So when the write shows up at the secondary, and the commit shows up at the secondary, it's immediately visible, even though that commit might not actually get quorum act everywhere. So you can read stuff that then later disappears. So it's a race condition. It doesn't normally happen. You have to have a bunch of failures at the same time. You have to have data loss. But if your system requires consistency, then it can get super scary. So typically we just say, don't do it. Unless you're very comfortable with those sorts of situations.
Here's a good way to think about it too. So if you're thinking about increasing throughput and scale out, then partitioning is the answer.
Or creating more service instances.
If you're interested in increasing reliability, then increasing the replica count is the answer. But generally, you don't use the secondary replicas for throughput. It's really more for reliability. So partitioning is really the answer there.
Yeah, I'd also really look at whether or not it's the transport. That's the bottleneck, or where that's a problem. I mean, the remoting's pretty good, but depending upon your data, you might gain some significant advantages by, switching the serialization. Marcin's a fan of GRCP, GCPRG.
GCPR.
Cool.
All right.
GCPR. Yeah, that's the
sold.
Yeah. GDPR?
No.
That's
Let's not get into that. We only have 30 seconds.
But yeah, so getting to the protocol, looking at the serialization of the protocol, and also looking at serialization within the store itself. So the collections let you, the reliable queue will not, the dictionary will let you override the serializer, and you might be able to get performance and efficiency gains there as well, not only in terms of the serialization speed, but also size.
Run the .NET profiler, because I bet you your hot path and where most of your CPU cycles are spent is in serialization.
Yeah.
Especially with
On and
data,
off the wire and down to the store.
Yeah, with data contract serializer, it's not the best.
Data contracted serializer.
Yeah, for remoting, it's everywhere, so you have to be careful with that. At least for collections, for primitive types or basic types,
We've already
we don't use data contract for that, but for complex types we do.
Yeah, if you're putting
So
keys anywhere, then you probably want to figure out what's going on.
Let's take this now.
Marston wants spans and serializer.
Any chance?
Jeez. I gotta get up to these new languages.
We're out of time, folks.
Okay, bye. But we are out of time.
We actually are.
But thank you all for calling in. There is the afternoon session in case you want more.
4:30 Pacific time. You guys are welcome to come back.
And I guess before we really say goodbye, we had some new attendees we should have introduced people.
Yes.
Yes, we do have new team members.
Why don't we say hello to the new team members?
Hello. Hi.
Introduce yourselves.
Who be around?
They're gonna find your names out sooner or later.
Yeah.
Oh,
That's
okay.
Yeah.
Hey, my name is Kavita Gowda. I'm the senior product manager in this team and trying to learn from all these great minds here. And one day I'll be able to contribute to you guys. Looking forward to it.
Still looking after those great minds.
What great minds.
And I'm Mackenzie Olson. I'm a PM intern doing my last year of undergrad at UW.
Cool. Nice.
Welcome.
All over. Wonderful. It's correct.
We were all noobs at one point.
Yeah,
Yes.
I mean, I have beginner brain.
Some of us are still noobs.
Yeah.
Yes.
Thanks, Ed.
Thanks, everybody.
Thanks,